What is the state of this liquid drop? Is in equilibrium. It's in equilibrium. Then the question comes like, what is the pressure inside that one that we are trying to calculate? Okay, let's get into, if I draw here a vertical line, tell me how the force due to surface tension will be. Best thing, if you're getting confusion, take lemon with a marker pen. You take lemon. I think I 3D diagram I can't show here. So take lemon or something. Lemon, you take it. You draw in a line on it. Then how the forces they'll be acting. So this layer one, layer two, no, layer one will try to pull the layer two. I have to show force like this. Similarly, the layer two will try to pull the layer one. The force here to show like this. This was the force due to surface tension. So if you separate this, if you break up this, this imagination is very important. So you break up this. You break up that lemon. I think when you break up, you're going to get two halves. Tell me like how do that forces I to show it? I think I'll show by red color. So here that red color arrow you have to show it here on the second, on the right of the lemon should be like this. Then on the fine force due to surface tension, things will be like this. So what actually doing is like you draw a line. The left off will be trying to pull the right off. The right off will be trying to pull the left off. And how do that force due to surface should be tangential. Everywhere it will be like this here. So what is this green color arrows? Why we have to show on the surface only? Why not inside? Because where surface tension will come only on the surface. Getting the diagram, what I've shown. Okay, now the liquid, what happened? It is in equilibrium. The reason for that, because of the pressure force P, because of atmospheric pressure force P naught into some area, and also due to force due to surface tension. So what I do is I am going to break up this drop. Let me analyze only one of the drop, one off of the drop. I'll break up this drop here now. I'll break up the drop. How the force, okay, this similar thing. Here I had to show only where on the surface here. And then here pressure will exert a force. So I think now you know enough of fluid dynamics. So the pressure force will act here in this direction. P minus P naught. So that everything will call delta P. So there's a pressure force, you write it. And this will be force due to surface tension. And the action of this, the drop is one off of the, I think it is understood, no? It is one off of the drop. Of drop, I'll write it. What is the at equilibrium? Fs equal to, or Fp is equal to Fs. What is Fp? Pressure P minus let me write here. So delta P into effective area pi r square. Why delta P? Because P minus P naught into effective area. So why we are not writing, but you can ask questions, sir, here half of the surface of a sphere, how much it be? 2 pi r square, here pi r square. I think you go back to the fluid statics, the force exerted by the liquid on the curved surface, it will see effective area, no? Because here the how it will exert force. I'll give one more diagram. What is there? Why to speak more unnecessarily. How the air will exert force. Will I agree? The force exerted by air and force exerted by the liquid inside will be like this. Force due to suffocation will be in this direction. I do. What is this? By the air will be like this. Huh? This force is by the air. By the air outside. The liquid inside will exert a force. So what is effective? Effective this one? It will see as if P naught into. So what is the pressure here? P naught. Here pressure also P naught. What is the average pressure? Will be P naught, and that will act at the center. And what is the effective area? It will see pi r square. And here the liquid, it will see effective area pi r square. So therefore delta P into pi r square. Force due to suffocation. Suffocation is Ft into 2 pi r. Because where do it will act? Only at circumference, no? Only on the free surface. So this excess pressure equal to how much? 2 St by r. So this delta P, what you can write? P minus P naught. This delta P is called as excess pressure. So where pressure will be more inside the drop, it will be more by how much of parameter? 2 Ft by r. And now where the pressure will be, so concave side, I think everyone knows if this surface, if I give this called as a concave, this called as a convex. Where pressure will be more on the concave side. Don't say inside the liquid, outside the liquid. Pressure on the concave side will be more than on convex side. By what parameter? 2 Ft by r. If it's a drop, 2 Ft by r. Like that, the drop is in equilibrium because of all this particular thing. Okay, green color, okay, able to understand. There is a force due to surface tension. So excess pressure means 2 St. What is the pressure inside the drop? Will be P naught plus 2 St by r. Similarly, we'll